Okay, in this video we will explain Bayes' theorem. Bayes' theorem states that if we have an event, and let's suppose that the probability of this event is between 0 and 1, then any other event can be split into two pieces. Here we have the whole probability set, and then if we have any event E, this is the event F, then any event E can be split into the intersection of E with F and the intersection of E with the complement, which is this part. This is the intersection of E with the complement of F. Therefore, the probability of E would be equal to the probability of E intersection with F plus the probability of E intersection with the complement of F. Notice that these two sets are disjoint. Therefore, we can go a little further and say that the probability, this is the probability of E given F times the probability of F plus the probability of E given the complement of F times the probability of F complement. And we need to, this is just the probability of E given F times the probability of F plus the probability of E given the complement of F, and the probability of F complement is just 1 minus the probability of F. This, even though it's very simple, is going to turn out to be very useful. Let's see an example that uses this theorem. If we consider the sample that is here on the right, we can define P, those people who is prone to have an accident, and then we have also P complement. Then we have the space is divided into those who are prone to have an accident and those who are not, right? And the information that is provided there says that 30%, that this probability is 30%, therefore this probability is 40%. The other information is a conditional probability. It says that if a person is in this group, then it will have an accident with a probability of 0.4. A will be denote the event that the person has an accident, and the complement is that it doesn't have an accident. Then in this case, this probability is 0.6, and it also says that if a person is in this group, then it will have an accident with a probability of 0.2, and it will not have an accident with a probability of 0.8. Then the first question is, what is the probability to have an accident within a year? Notice that when I multiply these two probabilities, 0.3 times 0.4, this gives us the probability of A intersection with P, and also this product, which is 0.7 times 0.2, this gives us the probability of A intersection with the complement of P. And then here we are using Bayes' theorem, and it says that the probability of having an accident would be the sum of these two, would be 0.12 plus 0.14, which is 0.26. What about the other question? What is the probability that if a person has an accident, that it comes from the group or from this group? Then that is a conditional probability, is if we know that it has an accident, what is the probability that it comes from this group? This is the probability of A intersection with P over the probability of A. But the probability of A, we just computed, is 0.26, and this probability is 0.12. This is 12 over 26, which is 6 over 13. Let's do another example. For this example, let's denote these two events. K is that the student knows. How to solve the problem, and C that the student answered correctly. Then we know that the space gets divided into two pieces. Either the student knows or the student doesn't know, and it is given that the student knows with a probability of P. Therefore, the probability of K complement would be 1 minus P. Also, if the student knows, then the student will answer correctly at 100%, and the probability is 1. But if the student doesn't know, then the student will answer correctly with a probability of 1 over m. And here we will have the complement would be 1 minus 1 over m. Then the question here is, if we know that the student answered correctly, what is the probability that he knows or he knew how to solve the problem? Then this is just the probability of K intersection with C over the probability of C. But here we know that the probability of K intersection with C is just P times 1, and the probability of K complement intersection with C is 1 over m times 1 minus P. Therefore, the answer is going to be the probability of the intersection, which is just P over the probability of C, which is the sum of these two. This is P plus 1 over m times 1 minus P, and this simplifies as P over n times P plus 1 minus P over m, and therefore the answer is just m times P over 1 plus n minus 1 times P. Let's finish this video by doing this example on the right. Here, let's denote by D the event that the person has the disease, and let's denote by E the event that the test was positive. Then the space can be divided into two parts. Either it has the disease or it doesn't, and the probability of having the disease is 0.5%, that means 0.05, and therefore this probability is 0.995. Now, if the person has the disease, the test would be positive with a probability of 95%. And if it will be negative with a probability of 0.05. On the other hand, if the person doesn't have the disease, the test would be positive with a probability of 1%, and it would be negative with a probability of 99%. Then the question is, what is the probability that the person has a disease given that the test is positive? Then this is just the probability of D intersection with E over the probability of E. Then let's see this. Here we have that the probability of D intersection with E, it is 0.005 times 0.95, and this is equal to 0.00475. This, the probability of D complement intersection with E, is equal to 0.995 times 0.01, and this is 0.00995. That means that the probability of E is the sum of these two, 0.00475 plus 0.00995, which is 0.0147, and then this conditional probability would be 0.00475 over 0.0147, and this is equal to 0.3231, approximately this. Then approximately 32.31% is the probability that a person has the disease given that the test was positive. Not that much.